Killjoy coming to spawn.
Okay. See, let's say we have a line 2x plus 5. Okay, ma? That is some
Okay,
line
sir.
like this, right? Let's say we have a line 2x plus 3. That is some other line like this. These two are parallel lines. Agreed, no?
Yes, sir.
Okay. When limit extends to infinity, both lines, or let's say the functions, function is f of x is 2x plus 5, and g of x is what? 2x plus 3. Okay. When
Yes,
limit
sir.
extends to infinity, both will tend to infinity, right? F
Yeah.
of x, x, so they both will tend to infinity. So that's why it is infinity. But limit extends to infinity, f of x minus g of x. What is that? It's actually equal to 2 only, no?
Yeah.
The difference, this difference is always 2, right? They are parallel lines, that is always 2. So
Yeah.
now that's why it is indeterminate, because in some cases it might be 2, in some cases it might be 4, in some cases it might be infinity also. So for example, if
Infinity.
f of x equals to let's say x cube, and g of x equals to let's say x square or x or root x, then the graphs, they will look something like this. This will go very fast, this will go like this, and the distance will not be constant, right? The difference will again be infinity. Understood, ma?
Yes, sir.
Yes, sir.
Okay. So that's why infinity minus infinity is indeterminate. Why it is indeterminate? Because we are not sure. It depends on the situation, basically, right? Why we are not sure? Because it always depends on the situation, right?
Will you hear? Will you mean?
Understood, ma?
Yes, sir.
Understood, sir.
Okay. So what we have discussed? We have discussed about 0 by 0. We have discussed about infinity by infinity. We have discussed about infinity minus infinity, right?
Yes, sir.
Okay. That's all. Anything else? We have discussed about 0 power 0 also.
0
Okay.
0.
Okay. Now let's discuss about one more thing. 1 power infinity. Okay.
1 power. Okay,
1
sir.
power infinity. 1 power infinity, you might say it's actually, again, like 0 power 0. Anything power infinity should be infinity, but 1 power anything should be 1. Right?
Yeah.
Okay. Now let's take this case. Let's take a small case, like let's say the x is approaching 1. Let's say from the right hand side, something like 1.1 power infinity. What will this become? This will become infinity, right?
Yes, sir.
Okay. But let's say x is approaching 1 from the left hand side. Let's say 0.9 power infinity. What will happen? This will approach 0. Agree?
Agreed, sir.
0.9 into 0.9 is lesser than 0.9, and again if you multiply, it will be still lesser than 0.9. So if you multiply 0.9 multiple times, it will approach 0. Right. 1.1 into 1.1 is greater than 1.1. If you multiply once more, it will go this way, right? One side it will
Yeah.
go this way, another side it will go this way. That's why we are not clear. Okay, ma?
Okay, sir.
Agreed, no?
Yes, sir.
Okay, so now we are clear. What are the 0 by 0 we have discussed? Infinity by infinity. Infinity by infinity, you are clear, right? We
Yes,
don't know.
sir.
What exactly is that? Okay. Another important thing is infinity power 0.
Understood, sir.
Infinity power 0. What will happen?
Break over the floor.
In infinity power, anything should be infinity, but anything power 0 should be 1. So that's why we are not clear again. Okay, ma?
Yes, sir.
Infinity power 0. Then another thing is 0 times infinity. Okay? Anything into 0 is 0, but infinity into anything is actually infinity. So we are not clear. Okay, ma? So we
Okay,
have
sir.
got
Okay,
all
sir.
these cases. Okay. Understood? So
Yes, sir.
see
Yes,
here,
Understood.
sir.
we are not including 0 power infinity. Why?
Sir, because
Yes, your answer is right. You're almost there. Tell me.
Sir, anything power infinity is infinity.
No, 0 power infinity.
So then it will be 0 itself.
It will be 0, right?
Sir, zero power anything is zero, but then
Ah,
at the
ah,
same
right,
time,
right.
anything
See,
power
that's
infinity is
let's say
also infinity.
let's
That's
approach from the right hand side and the left hand side. Okay.
Right hand side. Yeah.
0.1 power infinity is 0, right? Minus 0.1
Yes, sir.
power infinity, that is also 0. Agreed.
Yes, sir.
Agreed. Whichever side you approach, there is you are still approaching 0 only. That's why that is not there.
Yeah.
Understood?
Okay.
In these
Yes,
cases,
sir.
there is a
Yes, sir.
confusion. Say, for example, 1 power infinity, right side you approach, there is you are looking like infinity, and left side you are approaching, you are looking like 0. That's why there is a confusion, right? So this
Yes,
all
sir.
depends on the situation, which side you are approaching, what exactly are the values, how fast is this infinity, how fast you are approaching this one, etc., etc. Right? So, for example, infinity minus infinity, what kind of infinity is this? What kind of infinity is this, etc. Right? No, it
Yeah.
depends a lot on what kind of infinities we are talking about, right? And what kind of
Yes, sir.
approaches we are talking about, whether you are approaching 0 or 1 or infinity, what kind of approach and what kind of infinity, etc., etc. But in this kind of case, whichever is the approach, it doesn't matter, right?
Yes. Yes, sir.
Agreed, ma?
Yes, yes.
Okay, so 0 into infinity, it is nothing but 0 into infinity. You can actually convert this as 0 by 0, right? This infinity you can write it as
Yes,
1
sir.
by 0. So this is
Sir,
actually
1 by
equal to
infinity.
this is you can 0 into infinity. You can either write it as 0 by 0, or you can convert this as infinity by infinity, right?
Yes, sir.
This one you can. This is
Yeah.
actually a different variation of this two. Okay, ma?
Okay, sir.
Okay,
Okay.
so basically we understood about the different ones. We just understood that there are different types of indeterminate forms, but we still did not do anything on how to actually solve these kind of problems. Okay, we'll learn those also.
Okay,
And
sir.
why we are discussing this? Because we got talking about continuity, right? Continuity is,
Yeah.
Yes,
by
sir.
now we have realized, right? Continuity is heavily dependent on finding limits, right?
Yes, sir.
Yes, sir.
Yes, sir.
Continuity is heavily dependent on finding limits. So that's why finding limits is actually very essential. That's why we are discussing about various kinds of indeterminate forms. If it is not an indeterminate form, you can directly substitute, right? Yeah, mostly
Yes, sir.
so far we have reached these kind of cases, right? We have only handled these kind of cases, and what we did, we used LH rule. We just differentiated numerator and denominator and went ahead until we are getting something other than 0 by 0, right?
Yes, sir.
There are other
Yes, sir.
forms also which we'll learn how to handle. Okay, so for example, this one we can actually convert to 0 by 0, right?
Yes, sir.
Okay, this one we can convert to 0, 0. So we handle this case and we handle this case also. Here also we use LH rule, we handle this case, right? We have to handle these cases now. Okay, 1, 2, 3, 4. Four more cases are there. We'll handle in future also. Agreed, ma? Now,
Yes, sir.
if you are handling all these 7 cases, then by default limit is just substitution. Otherwise, if it is not falling in
Yes,
these
sir.
7 cases, what does that mean? That is plain substitution, right? Right, ma?
Yes, sir.
Not yet.
Okay, now if you are able to handle all the 7 cases properly, that means you are handling all the limit problems and as well as all the continuity related problems. Agreed?
I
Yeah,
agree.
Okay,
agreed, sir.
so we'll come here. So let's this all we have finished, no? This all we have finished, no? Ma?
Yes, sir.
Limits, basics, these are all we have finished. Did I send you this one? I did not send, no? I don't
Sir,
remember.
No, no, sir.
Okay, I sent
sir,
this
it's the
one.
book name Thomas Calculus 12th
Okay,
edition.
this is Thomas Calvin's book, but these are slides which I picked from multiple places also. Okay,
Oh,
Oh,
okay,
okay.
sir.
okay. So for this kind of exercises
Yes.
we have done now. How to calculate limit? This is actually in the form what? This is 0 by 0. This is 0
Yeah.
by 0. No? What we have done, we have rationalized. You know this, you know? How do we just rationalized and we realized there's a common factor. This h and h,
Hmm.
this h and h are making the zeros in the denominator. We remove the common factor and then we are good to go, right?
Yes, sir.
Okay.
Yes, sir.
In this case, what we have done? In this case, we have realized 1 minus x is the common factor, or x minus 1 is the common factor in both the numerator and denominator. We remove that and we are good to go, right? So when both numerator and denominator are becoming 0 together, that means there must be some common factor. This is what we were doing here, right? In this
Yes.
case, I think similarly we have done something, right? In this case also, is it 0 by 0? Right, 0 by 0. We have simplified this and then we removed a common factor. What is that common factor? I think x is the common factor, or we removed x. Oh, okay. I think there
Sir,
is
how did limit x tends to 0 become x tends to 1 in the
I
next
think there
step?
is a printing mistake here.
Oh,
I think that is the reason. Okay, with the common factor is the x, right?
yes, sir.
Okay, now, so that we removed and we were good to go. In this case, what we did, it is again 0 by 0. We rationalize the denominator. This process, no, rationalizing numerator or denominator, right? This is
Yes,
pretty
sir.
straightforward. Okay. See, in this case, what you have done, again rationalizing the numerator. The common factor probably should be x square, right? There's a common factor x square. We remove the common factor. It is
Okay.
making both numerator and 0 together, right? I think we discussed this
क्या
one.
ही अमाउंट sorry sir
Okay. So, did we discuss this? Okay, just think about this. Limit x tends to 1, f of x equals to 5. Okay. So does that mean f should the f of 1 should be defined? Need not be, right?
No need to.
No need, right? F of
Yes,
1
sir.
limit is about what we are approaching. It doesn't matter what is the value of the function, right?
Yes, sir.
And even if it is defined, should it match the limit?
No, sir.
No need, right?
It
It
need
can be
not be.
anything.
Need not to
It
match
need not
this.
be, right? What about this one? F of 1 is defined. Does that mean limit exists at 1?
No, sir.
It need not be, right? Need not be.
Yes, sir.
Limit might exist. The f of it could be like this. Probably f of 1 is actually 5. Doesn't matter, right? Now, and let's say if it exists, then should limit x tends to 1 f of x should be equal to 5? This is interesting. If we know limit exists at 1 and f of 1 equals to 5, should it match 5 or it could be anything?
Sir, it could be anything.
It could be anything, right? It could be something like this, right? And this could be 5, right? No?
Yes, sir.
It could be anything. Very good. This is plain common factors, right? Common factors we have
Yes, sir.
cancelled. Here also common factors we have cancelled. Here also I think some common factor, right? Common factors we have
Yes, sir.
cancelled. And here also we cancel a common factor, right? These are very simple ones, right? In this, just see here also you can bring a common factor, right?
Yes, sir.
Be little careful here. X here this one we can write it as 2 plus root x into 2 minus root x. So basically here also a common factor. Very good. So here we rationalize, right?
Yes, sir.
Okay, here we rationalize, and what is the point of rationalization always? It is generally to remove that common factor, right? No?
Yes, sir. To cancel.
Okay. Now this is interesting. Can you tell this?
Sir, it becomes
Be
normal
little
x plus
careful.
2 only
Take,
because
take,
my x tends
ah,
to minus 2 plus. If it's minus, then you need to add minus in it.
okay. Little careful. Tell me what he is doing here.
Sir, you just changed mod of x plus 2 into x, normal x plus 2 only.
Normal x plus 2y.
And then cancel the terms because
No,
it's
no.
minus 2 plus. X
What does
tends to
that mean?
minus 2 plus. That's why.
What does that mean? This is minus 2, right? We are approaching from the right side, right?
Yes, sir.
So, x plus 2 will become what? Will it be positive or negative? When x
Sir,
is greater than
positive
minus.
itself.
So, that's why we are doing this. What about this case? X plus 2 will become
Sir,
negative.
here it becomes negative.
Very good, very good. Shreyas, clear now? Shreyas, you are on mute. Okay. So, okay, let's continue anyway. You understood, Nama? The limits, they are not matching. That's why this limit doesn't exist. Okay. In this case also similar case, right? When x tends to 1 plus x is greater than 1, then this becomes positive. X less than 1, this becomes negative. Okay?
Okay, sir.
Okay. Okay. Now, what about this one? Do you agree with this statement?
Yes, sir.
Okay. So, step of 3 plus, let's say step of 3.1, right? that becomes 3 only. So that's why the limit is 1. What about this case? Do you agree with this?
Yes, sir. This is also correct only.
This also. What about this one?
Sir, this is also right.
This is also right. Wait. This one?
Sir, this is also right.
Okay, very good. Now another interesting thing. We discussed about this, right? What is the limit? This limit is equal to 1. Right?
1.
This limit is equal to
Yes,
1.
sir.
And what essentially we are saying, sin x, the graph is something like this, right? And at 0, the graph of sin x and y equals to x, the more or less they coincide, right? That's why the value is actually getting closer to 1. Now, how do we do this? 1 minus cos 2 theta. What is 1 minus cos 2 theta? 2 sin square theta
2
by 2,
sine
right?
square.
No?
Yeah.
Right. So that's why it's doing minus of this one. Now what we are doing actually here? We know sin theta by theta and we have 1 theta extra, right?
Yes,
1
sir.
sin theta extra. So this becomes 1 and there is already a sin theta. So that's why this total becomes 0. Understood? Limit.
Understood, sir.
Are you clear with this? Shreyas, you are clear, ma? Shreyas is there or dropped? Is he facing any internet issue?
Sir, I don't know. Sir, if he did, then he would have messaged me by now. Or here at least.
One minute.
Think
It means
he's-
Sir, hello.
Ma, can you hear me?
Yes, sir, I can hear you.
Okay, cool.
No, sir, I muted myself because there were background sound and my mom
Okay,
came
cool.
back.
You're able to hear, no? These
Yes,
kind of
sir.
problems, these are pretty easy, right? 3 by 4 or k by 1, whatever, right? No?
Yes, sir.
1 by
Yes, sir,
3.
very easy.
These are very easy. 2 by 1, whatever. Okay? These are basic problems. And these kind of problems, you just need to little bit manipulate these ones so that you get in sin theta by theta or whatever. Okay, ma? These little manipulations you can do, right? No?
Yes, sir.
Okay? 1 minus cos 2 theta. So okay. Can you try this one? This one.
Yes, sir. That's
Just
fine.
try a bit.
Shoot.
You just need to manipulate these ones to get in the format that you want. Okay?
Okay, sir.
Okay, sir. So the answer is 0.
You got 0?
Yes, sir.
Okay, very good.
Sir, we make 1 minus cos theta as 2 sin square theta divided by sin theta, and then once we
Right,
cancel from the...
right. So basically 1 minus 1, sorry, wait, come again. 1 minus cos theta.
Sir, I made it to 2 sin square theta.
2 sin square theta by 2, no, that is.
Oh, yeah. Oh,
So you should be little careful. Here you will get 2 sin theta
yes.
cos theta.
Sir, even if we do that same answer, cos sin theta
Okay,
is
fine.
the...
You will get the same answer. Ideally, you should get the same answer because you will get a sin theta in the denominator and a cos theta, right?
Yes, sir.
Okay. So that is fine. Shreyas, you also got number? Okay, so we are discussing about 1 power infinity kind of thing, right? Okay, let us discuss one very important thing. 1 plus x whole power 1 by x when limit x tends to 0, right? So this is in what format? When x tends to 0, this is in the format of 1 power 1 by 0, which is infinity, right, Nama? Agreed?
Yes, sir.
Okay, 1 power infinity. This is in the format of 1 power infinity. We want to calculate what exactly is this? Is this limit? Okay. So now what we do, we'll take this function. Okay. We take this function as y equals to 1 plus x whole power 1 by x. Okay. Then what will happen to ln y? We are taking logarithms on both sides. 1 by x ln 1 plus x. Agree, ma?
Sir, what is ln now?
Natural logarithm. We are taking log. See,
Oh.
log 10 means to the base 2, right?
Sir, I don't know this, sir.
Okay.
Sir, we
So,
weren't taught this.
okay, logarithms,
Sir,
log
we
8,
don't know logarithms.
log
Sir, the
8 to the
only thing we
base.
know is derivative of log x is 1 by x.
But
That's
what
the
is
only
that
thing
log
we know.
x? Log 8 to the base 2 is 3. This one, you know?
No, sir.
Okay, fine. Let's
We don't know
say,
anything related to logarithm.
okay. Let's say, okay, fine. Let's say 2 power 3 is 8. Agreed?
Yes, sir.
Okay, so then this is something like 8 is 2 raised to what power? Right, 8
Yeah.
is 2 raised to what power? 3, right?
Yes, sir.
So we write like this. Log 8 base 2 is actually 3. Understood?
Oh,
Okay, log 8 to the base 2 means if you raise this 2, if you raise this base to what power you will get 8. What does this mean? This means that. Okay. So for
okay, sir.
example, log 100 base 10. What does that mean? If you
It's
raise
10.
10 to what power you will get 100? You will get 2. Agreed, ma?
Agreed, sir.
Agreed, sir.
Agreed. Let's say log 27 to the base 3. How much is this?
Sir, it's 3.
It's 3. That means what? 3 raised 3 times
3 cube is 27.
3 cube is 27. Log 81 base 3. How much is this?
4.
87. This is actually 4. You understood, no? Okay. So
Yes, sir.
now there is some number called E. Okay. This number is an irrational number, 2.7 something, etc. Okay. Now, just
Okay,
like you
sir.
are taking this base 2, if we take that base as E, instead of writing log 10 to the base E, we'll directly write it as ln 10. ln 10 means we are replacing this with ln. Okay? Natural logarithm, we call this.
Okay, sir.
Okay? So, you would have seen, we have discussed about e power x, no?
Yes, sir.
What is that e power x? We have discussed that this is a graph, it looks like this, right?
Yes, sir.
Okay, and what is this E? What is so special about this E is this graph is there, no? What is the specialty of this graph? At any point, if you calculate the slope, okay, at any point you calculate the slope value of the slope is equal to value of this function. Understood?
Yes, sir.
Okay, so for example, let's say at x equals to 3. Okay, what is the value of the function? E cube, right?
Yes, sir.
But d by dx of the slope of e power x is anyway e power x, right?
Yes, sir.
Which is nothing but e cube, right? Agree, ma?
Agreed,
Sir,
sir.
can you come again? I didn't understand.
Okay. So, what mathematicians have decided is, let's say they went for a quest. What is the question? Is there any function? Is there any function? Any function whose slope equals value of function? Slope equals value of function. Understood?
Yes, sir.
Okay. So what they have realized is there are a lot of functions, all the exponential functions. So for example, 2 power x, 4 power x, 4 power x, these are a lot of functions. If you try to calculate the slope, no, you are getting actually proportional to this number. Okay. So for example, what is the slope of this one? A power x, what is the derivative? Tell me.
Sir, a
What is
power x itself.
no. E power x is e power x. A power x, we'll call it ln a. Okay, never mind.
Oh,
Okay, so what we are trying to say is, let's say 2 power x. If you try to draw the graph, it looks something like this. Agreed, ma?
agreed, sir.
Okay, now the slopes are always increasing. Agreed? The slope here versus slope here, the slope is increasing, right? At
Yes,
any
sir.
point, the slope is increasing. What we are just saying this slope is proportional to value of the function at that point. Understood? So the slope
Understood, sir.
here
Understood, sir.
is greater than the slope here. Okay. And what we are saying, the slope is actually equals to some k times the value of the function. Okay.
Okay, sir.
So for example, if it is y equals to x, the slope is constant, right? M is constant.
Yes, sir.
Okay. But these are those functions. What are these functions? Exponential functions, where the slope is actually proportional to the value of the function. Okay. So let's say the opposite. You would have in chemistry, you would have heard about half-life, right?
Half-life? No, sir.
Half-life you did not hear?
No,
Half-life
sir.
period
sir.
and also, okay. Okay, so there are some radioactive materials, okay?
Okay, sir.
Radioactive materials or carbon dating, etc., etc. Okay, what happens? They will have certain half-life time. What does that mean? If there are 100 units and 5 years is the half-life, then what will happen after 5 years? This 100 will become 50. Okay, and in the next 5 years, this 50 will become 25. Okay,
Okay, sir.
this is called
Okay, sir.
half-life. In what time, whatever is that quantity, will become half. Okay, just wait.
Okay, sir.
I'm just coming. This is called half-life. I think you should get in this year physical chemistry. You will get this also. Radioactive decay and all.
Oh,
I'll just come on. Just wait.
sure, sir.
Hmm. Okay. So this is radioactive decay. Radioactive decay means certain items. Let's say, for example, radium and all. Okay. What
Okay.
happens? Whatever is the amount after certain time that will become half. Okay.
Okay, sir.
That is called radioactive decay. So every time in the next 5 years it will become half. Right. So
Yes, sir.
let's say certain amount is there. After 5 years, what is the amount? That is proportional to what is the amount right now. Agreed?
Sir, that means it will never become zero.
It will never become zero. Right. Exactly. That's the
Yes, sir.
whole
It
point.
will tend to zero, but then
It will tend to zero, but it will never become zero.
No, it never
Exactly.
becomes zero. Yeah.
Right. It will get as close to zero as you want, but it will never become zero.
Zero.
Right. So,
yes, sir.
so for example, let's say the population of fish in a pond. Okay. If there are 100 fish, then let's say that will become 200. If there are 200, that will become 400. Right. This is always proportional to what is the fish at that particular point. In the next, let's say 1 month or 2 months, right? This is
Yes, sir.
exponential growth. Or say, for example, take some other example. Let's say interest, interest rate.
Okay, sir.
Right, interest amount. ఇక్కడ పెట్టారా నాకు తెలియదు ఇందులో పెట్టారా పొద్దున్న ఇందులో పెట్టారా ఇక్కడ పెట్టారా అంటున్నా ఎంతమంది కాదు అక్కడ పెట్టాను బాబు నేను ఆ టేబుల్ మీద ఉండాలి చూడు పొద్దున్న టేబుల్ మీద తెచ్చా కదా కార్ తానే పొద్దున్న తెచ్చానే కింద వదిలేసింది తెచ్చా నేను అదే ఆ టేబుల్ మీద ఉంది డాడీ కింద ఉన్నారా నాతో 20 minutes ఆగమని వస్తా 6:30కి అయిపోద్ది So, for example, interest amount is always proportional to what exactly is the total principal plus interest till that point, right, Nama?
Yes, sir.
Yes, sir.
Okay. So similarly, what exactly we are saying is in an exponential function, whatever is the exponential function, the slope of the function, what is slope? Slope means rate of growth, right? What is the derivative? Rate of change, right? No?
Yes, sir.
Slope means rate of change. Rate of change of that function, let's say rate of change at amount, or rate of change of whatever amount that is left, or rate of change of whatever number of fish that is there, is always proportional to the amount of fish at that particular point. Agreed? Agreed, no? If there
Agreed,
is
sir.
less fish, there will be lesser in the future. If there is more fish, there will be more in the future. If there is more large amount of radioactive material, next time also the proportional to that there will be they will be the amount that will be the amount of radioactive material, right? Now
Yes, sir.
that increase or decrease is always proportional to whatever that you have got right now, right? If the outstanding amount is big, then the next amount will be bigger. If the outstanding amount is smaller, next amount will be smaller, right? Rate of increase
Right, sir.
or decrease is proportional to the amount that is right now there, right? So,
Yes, sir.
so the interesting thing is when mathematicians were discussing about or investigating these kind of functions, they realized all these exponential functions, no, 2 power x, 4 power x, 7 power x, whatever, all this they have common nature. What is the nature? The rate of growth is proportional to the existing one, right? This happens a lot in the nature, right?
Yes,
Agreed.
Yes, sir.
Right. Now of all this, then what is the next natural question? The question is, what is that function whose rate of growth is exactly equal to the value of the function? Okay. So they have realized 2 power x is proportional to 2 power x, but not exactly 2 power x. So then they realized that function is actually e power x. Right. E power x, that's why the derivative is actually e power x. What does that mean? The rate of growth of e power x is actually equal to e power x, whatever is the point. Agreed, ma?
Agreed, sir.
Okay, so now because E is that particular number and this it has got this beautiful property, what they have done, they have defined all the logarithms with respect to E. Okay, instead of defining log 10 base 2 or log 10 base 10 whatever, so they have created logarithm tables to the base E. Okay, which is what they called as natural logarithm. Okay. So, for
Okay,
example,
sir.
when you say ln 10, what does that mean? This e, which is roughly 2.7, e raised to what number is actually 10? Understood?
yes,
Understood, sir.
Okay, e raised to what number is actually equal to 10?
10.
Okay,
Okay, sir.
okay. So,
So,
for
so for
example,
all the natural logarithms, CU must be there.
whenever you see ln, it just means log to the base e, whatever is that number.
Okay,
That's it.
sir.
That's it. Instead of writing log to the base e, they will just mention it as ln. Okay.
Okay, sir.
Okay.
yes, sir.
Okay, so for example, now let's say uh, 8 equals to 2 cube. Okay, then this we just discussed log 8 to the base 2 is actually equal to 3. This automatically means this, right?
Yes, sir.
So in a way, what we actually say is in this case, we take logarithm on the both sides. That means log 8 to the base 2 equals to log 2 cube to the base 2, right?
Yes, sir.
Okay, so then what we are essentially saying is 2 raised how many times will become 2 cube? That is nothing but 3. Right now?
Yes, sir.
Right. So that's what we say here. Log 8 to the base 2. Instead of log 8 to the base 2 is we can also write it as log 8 to the base c, which is nothing but ln 8. Natural logarithm 8. Okay, ma?
Okay, sir.
Okay. So now the point here is a power x. If you differentiate, you will get a power x ln a. Okay.
Okay,
That
sir.
means a power x logarithm of a to the base e. Okay, if this a is e, then what will this become? E power x logarithm of e to the base e. E raised how many times will become e? This will become 1. So this is actually equal to 1. So this becomes e power x. Understood?
Understood, sir.
Okay, so now in this kind of function, okay, so why we are doing all of this is, let's take this function 1 plus x whole power 1 by x when limit x tends to 0. Okay,
Okay, sir.
this is looking like 1 power infinity. So let's take this function y equals to 1 plus x whole power 1 by x, and now let's take logarithm on both sides. Okay,
Okay, sir.
okay, so now ln a power m equals to m ln a or m log a, right?
Yes, sir.
Agree, no?
Agreed, sir.
Okay, so this becomes 1 by x ln 1 plus x. Okay, ma? Which is nothing but
Okay,
ln
sir.
1 plus x by
Sir,
x.
so are there 1 by x is the base and then 1 plus x is the
No. So,
actual?
so this means log 1 plus x to the base e whole by x. This means.
Oh, okay, sir.
Understood?
So 1 by x is not a part of logarithm.
Now, x is not part of this.
Okay, sir.
Okay, so that's why we write it as ln 1 plus x by x. Now this becomes 0 by 0 format. Okay,
Yeah.
so otherwise what we will do, we'll discuss this little later, because before this we want to understand thoroughly what are logarithms. Okay,
Logarithms, yeah.
okay. Tell me one thing, in our class 10th or something, have you seen these kind of things? Log a b equals to log a plus log b, these kind of
No,
things.
sir.
Not
Sir,
at
in
all,
10th
sir.
we didn't have logarithm. Even in 11th also we didn't have logarithm
Okay,
except
okay.
for
Log a by b
log x
equals
plus
log
by
a
x.
minus log b. These kind of
No,
things
sir.
you don't have, no?
No,
No,
sir.
sir.
Okay, good.
Sir,
Then
all we
we'll.
had was once in 11th, that was log a by b. I mean, log equal to 1 by x.
Oh, okay. I think because of this COVID rationalization, they have completely removed these logarithms from your syllabus, I think.
Oh,
Okay.
yes, sir. Half of them were deleted also.
Right. Because of that. Okay, fine. Never mind. Then what we will do, we'll park this a bit right now. Okay.
Okay, sir.
Because before this, we need to understand what exactly are logarithms. Okay. Little bit of properties. Next class, whatever, probably tomorrow only, we'll discuss what are
Yes, sir.
logarithms. Okay. Why are they
So
important,
next
etc.
class is on Saturday.
Tomorrow is there, no?
Yeah,
This week,
yes, sir. Tomorrow.
this week,
Because
today and tomorrow is
Monday
there. Next week
we didn't have
onwards,
on Monday.
Oh, okay, sir.
Monday, Wednesday, and Saturday, no?
Yes, sir. This
Oh,
time
okay,
you
sir.
missed Monday, so we
Yes.
Thursday.
This
Yeah.
time, today is Wednesday, Thursday, and Saturday. Okay, ma?
Okay, sir.
Okay. This
Yes,
for this week we will follow this one. From next week onwards, we'll follow
Monday,
Monday,
Wednesday,
Wednesday,
and
and
Saturday.
Saturday. And what is the time? It is 2 p.m. for you, right?
No, sir.
No,
Three,
sir.
three,
3.
Oh,
three,
sorry,
three.
it is 3 p.m. for you, and it is
No, five
5:30 for
thirty.
me.
3. Yeah.
5:30 p.m. for me. Right now?
Yes,
Yes,
sir.
sir.
Okay, cool. So this week, today, tomorrow, we'll follow this. Okay. Okay,
Okay,
so
sir.
Sure.
then let's park this limit a bit. Okay, so let's park this limit a bit. 1 power
Sir,
infinity.
so Saturday it's in the morning time.
Saturday in the morning time. Saturday it is, I think, for you 9. For me it is
Yes, sir.
11:30.
9.
Yes, sir.
Right?
9 o'clock.
9 and
Yes, sir.
11:30. Okay. Yes. So this one power infinity. Let's park a bit. Okay. In fact, 1 power infinity. All the other ones. Where is it? 0 power. The power infinities. Or the other cases which we have seen, no, indeterminate forms. Okay, indeterminate forms, let's park a bit and we'll get there once we finish logarithms. Okay, so then
Okay, sir.
did we discuss about the differentiation piece? What exactly is the differentiation? Okay, so did we discuss this graph?
No, sir.
Okay, cool.
No, sir.
So we know slope of a line. What is slope of a line? Y2 minus y1 by
Y2 minus Y1 by X2
X2
minus
x2
minus
X1.
X1.
minus x1, right? Right. So if there are 2 points x1, y1, what is the slope? Y2 minus y1 by x2 minus x1. Okay.
Yeah.
Let's say there is a function y equals to f of x, that is this blue line. Okay. Okay. So what
Okay,
does
sir.
that mean? Let's say 2 points x naught. Let's say x naught, and let's say whatever x2. Okay. Or whatever. Take these two points. What is the value of the function at this? It is f of x naught, right? And value of the
Yes, sir.
function here is, what is f of x naught plus h, right? What is this point then? x0 plus h and f of x0 plus h, right? If this one is, if we call it as x1, y1, what is x1, y1? x1 is x0, right? What is y1?
Yes.
f of x0, right?
Yes,
And if
sir.
we call it x2, y2, what is x2 here? x2 is x0 plus h, right? And what is y2? f of x0 plus h.
F of
Agreed,
x
ma?
plus h.
Agreed? Now what
Yes,
will
sir.
become of our y2 minus y1? y2 minus y1 is f of x0 plus h minus f of x0, right?
Yeah.
Yes, sir.
And what is x2 minus x1? x0 plus h minus x0, which is nothing but h, right?
Yeah.
Right. So essentially what we are saying is the slope of this line, this black line, is f of x0 plus h minus f of x0 by h, right? We are just saying the slope of these two, this line connecting 2 points. And what about the points? The points are, one is x0 and the second point is, instead of writing it as x0, we are saying the second point is h units away from x0. Okay, ma?
Okay, sir.
Okay. Then what is the slope? This y2 minus y1 by x2 minus x1. x2 minus
minus
x1
x1.
is actually h. Okay. So now what we are saying, this line is connecting 2 points, right? Okay.
Yes, sir.
Now this point comes closer and closer. Okay. This by the way, this black line we call it a secant. What is a secant? In a circle, what is a secant? This is a secant, right?
Yes, sir.
In a circle, what is a tangent? This is a tangent, right?
Tangent, yeah.
What is the difference between secant and tangent?
Sir, secant is touching 2 points of the circle, but tangent is
Tangent
only
only
touching
touches
one
one
point.
point.
Fantastic. So basically, in a circle, if I move the secant a bit until it touches one point, that will become a tangent, right?
Yes, sir.
Okay. So if the 2 points, it is touching 2 points, no, in a circle. If the 2 points are getting closer and closer, right, then that secant will become tangent, right? If the 2 points
Tangent,
coincide,
Yeah.
but basically it becomes a tangent, right? So similarly, here also, if this point is here, then this black line would have moved like this, right? The point is here,
Yes, sir.
etc., etc. If the point comes closer to this point, basically, if both the points coincide, what is the secant? That secant will become tangent, which is nothing but this pink line.
Red line.
Agreed?
Okay.
Agreed, ma?
Yes,
So,
sir.
Okay,
and
sir.
if these 2 points have to coincide, what does that become? H should become 0, right? So, essentially, what we are saying, limit h tends to 0, f of x0 plus h minus f of x0 by h will give you the slope of this pink line. Agree?
Agreed, sir.
Agreed, no? And what we are saying, the slope of pink line is actually slope of the curve at that particular point. It is not the slope of black line. Rather, what is the slope of the curve? It is actually the slope of the tangent at any point. Agreed?
Yes,
By the
sir.
definition, what is the slope of any curve? The slope of a curve is equal to the slope of tangent at that particular point. At this point, the slope is different, right? At this point, the slope is different. But what is the slope? The slope is actually equal to the slope of the tangent. Agree, ma?
Yes, sir.
This is what we are saying here. What is the slope of a curve? Do you agree with this?
Agree, sir.
Yes, sir.
Agree with this, no? Right. Now,
Yes, sir.
let's say the curve is something like 1 by x squared. 1 by x. Okay? Let's say the curve is 1 by x.
Okay, sir.
Okay. Now, how do you find the slope of this curve? You know, d by dx of 1 by x is actually equal to what? Minus 1 by x square, right?
Minus 1 by x square.
Minus one
Minus
by
1 by x. So
square.
you know this. But how did we get this? That is the important question. Okay? Because in the textbook it is mentioned like this. But who told this? How did they derive this? Right? That is important. So let's start from the base principles. What is the principle? What we have discussed, at any point, what is the slope of a function? F of, let's say the point is a, f of a plus h minus f of a by h. Agreed?
Yes, sir.
Yes,
Okay.
sir.
We'll take a point here and we'll take this line. This is a plus h, right? This is a plus h. y2 minus y1 by x2 minus x1. That's what we are doing here. y2 is f of a plus h, y1 is f of a. Okay, ma?
Okay, sir.
Now,
Okay,
what
sir.
is f of a plus h? F of x equals to 1 by x. F of a plus h should be 1 by a plus h, right?
Yes, sir.
Okay. Minus what is f of a? F of x is 1 by x, so it should be 1 by a, right? Now, what will become of this? This becomes Okay, what will become of this? A minus A plus H, right? By H times A plus H. Agree?
Yes, sir.
Agreed, sir.
Okay, so what will become here? These two will cancel. We will get minus H by H times A plus H. This H and this H will also cancel. We'll be left with what? We'll be left with minus 1 by A times A plus H. Right, this limit will still continue. Now at this point we can substitute the H equals to 0, right? Here we could not
Yes, sir.
substitute. Basically what in the entire process what we have done, we have removed a common factor. Right. Now if you substitute H equals to 0, what will be left? Minus 1 by A square. Agree?
Yeah.
Agreed,
Okay,
sir.
so that is how we have reached minus 1 by x, the derivative of or slope of 1 by x at any point is actually equal to minus 1 by x square. At a point A, this is equal to minus 1 by a square. That's how we arrived at this formula. Okay?
Okay, sir.
Okay, this is the fundamental process. Okay, so when you were given lot of derivative formulas, right? You would have what is d by dx of sin x, d by dx of cos x, whatever, right? All the
Right.
formulas
Yes, sir.
someone sat through and did these kind of calculations and calculated the limits. Okay, so all of the formulas, derivative formulas that you are seeing now, they're actually limit problems. Okay, they have done some kind of rationalization, factorization, whatever, and arrived at those results. Okay.
Okay, sir.
Okay, so for example, what is the derivative of this? Minus 2x, right?
Yeah.
Yeah.
Okay, minus 2x. But someone has already told you that x power n derivative is nx power n minus 1.
Nx raised to n minus 1.
Right. But here, if you don't know the formula, but still there is a way. What is that way? Again, f of x naught plus h minus f of x naught.
Minus fx by h, first principle.
Right. First principles. Right. What is x naught plus h? Here we want to calculate it minus 1, right? So that
Yeah.
is this. You are replacing x with minus 1 plus h. Here, this is f of x, right? This is f of x. This is f of x plus h minus h, right? Now, if you expand this, you will get this. Agree?
Yes, sir.
Agreed. This one and this one,
Sir,
will
sir,
get
can you
cancelled.
tell me how there is 4 minus of minus 1 plus h the whole square?
Okay. So, what is f of x plus h? F of x is,
Oh,
wait. F of x is 4 minus x square. Okay.
yes, sir.
What is f of minus 1 plus h? X replaced with minus 1 h, no?
Yeah, I understood, sir. Minus
Okay.
1 plus h the whole square.
Okay. You just replace x with this one, right?
Yeah. Yes,
So,
sir.
because why minus 1 plus h? Because we want to calculate slope at minus 1 at this point, right? At minus
Yes,
1.
sir.
Agreed, ma? So, now what we are doing, we are just simplified this. Essentially, what we have done, we have removed the common factor of h. Okay? Now we can substitute h equals to 0. What is the slope that you have got? The slope that you have got is actually 2, right? No?
So, yeah.
This is the 2. Now, what is the tangent? The line is passing
Minus
through a
1.
point and you know the slope. The slope is 2 and line is passing through the point, so you know what is the tangent. Agree?
Yes, sir.
So, without knowing this, we have actually derived this. So, there is a proof for this also. Why for any x power n, it should become nx power n minus 1. Okay. Because it is not so straightforward. No. Why is that the slope of this curve is actually equal to this one? This you can derive this also. Okay. By
Sir,
this,
so y is supposed to be 2, right? Because 2 1 is 0.
what ma?
Sir, so answer of y is 2, right?
Answer of y is the equation, no? So, the slope is 2. Agreed. The slope is 2. So, the slope of this line is actually equal to 2, no?
Yes, sir.
The slope is 2 and he is asking about what is the equation of the tangent at this point. So y minus y1 equals 7 times x minus x1 he has done. Okay.
Okay, sir.
You know a
Okay,
point,
sir.
you know the slope. So he derived what is the equation of the line. Okay. Okay. So again, something like this. X minus 1 whole square. Okay. So if we have to do, you will do something like this, right? The derivative is this, right? Derivative of this function, right, Nama?
Yes, sir.
Yes, sir.
Instead of that, what we are doing from the first principles. What is the slope? F of x naught plus h minus f of x naught by h. And what is the value at which we are evaluating? It is 1 plus h. Right, x replaced with 1 plus h. Okay, ma? 1 plus h minus 1 whole square plus 1 by what is f of x naught? This is just x replaced with 1. Okay?
Okay, sir.
Agreed. So now this is massively simplified. Here we are getting the slope equals to 0. Fine. Anyway, we are also getting the slope equals to 0, right? X equal to 1. 2 into...
Sir, our other tuition started, sir. The CBSE batch one started.
What more?
Sir, the CBSE batch tuition started right now, sir.
Oh, okay. Cool. Please continue. Take care. We'll connect tomorrow then.
Okay, sir.
Okay, ma. Bye-bye.
Okay, sir.
Thank you, sir. Bye, sir.
Sir, can you explain how we find y tomorrow again?
Right. I'll
Like the
explain.
slope is fine, then I didn't understand how we find y.
Which one? This one, the equation of the line.
Yes, sir.
Equation. You
Yeah,
don't
which
need to go
formula
there.
use for y?
You don't need to go to the other tuition.
So I also have to go.
Okay, I'll explain then. Just wait. So there is a point, right? What is the
Yes,
point?
sir.
-1, 3, right?
Yes,
And
sir.
what is the slope? Slope is 2, right? You know
Yes,
the
sir.
point and you know the slope. What is the equation of a line? Y minus y1 equals m times x minus x1, right?
Oh yeah, now I get it, sir. That
Okay, y
formula.
minus 3 equals 2 times x minus x plus 1. Okay, this is what he has
Yes,
done.
sir. Now I get it.
Understood, no? Okay.
Understood, sir.
So,
Thank you, sir. Bye.
okay, you go ahead. We'll discuss the remaining tomorrow. Okay, ma?
Okay, sir. Thank you,
Take
sir.
care. Bye-bye.